Okay, this slide that you're looking at right now is an essential slide for micro. You don't only have to know the steps, you have to know the why behind the steps. Okay? So I can almost 100% guarantee that this will either come up on your practical as an essay question or it'll come up in your lecture as an essay question. And if you just give me steps and no explanation as to the why, that's not going to work. So make sure you understand this. Okay? Gram staining is one of the key things that we do in micro to help us narrow down what bacteria we're looking at. I told you that we have the gram negative and gram positive. Most bacteria fall into one of those two categories. If I can tell which one it is, I can narrow down which bacteria I am looking at. Okay? It's important to understand what's happening at each stage of this process, both what the cells what the cell looks like microscopically and what is chemically happening to that cell wall. So you have four chemicals that you are going to use. Okay? Well, actually five if you include water. You've got crystal violet. Okay? That's an actual pen, not the one that goes to the computer. You've got crystal violet, grams iodine, alcohol, and safranin. Okay? So the only other thing that you are going to use is water. All right? So crystal violet, you've made your bacterial smear and it is prepped and ready to be stained. Crystal violet is going to be the first dye you use. You add the crystal violet to the cells, and it is going to sit for, I believe, 1 minute. And what's going to happen is that crystal violet is going to embed itself into the cell wall, which you can see there. Okay? Now remember, gram positive have this thick ginormo cell wall, right? Gram negative have this thin section of cell wall with peptidoglycan. So crystal violet sits for about 1 minute and you've got this staining of the peptidoglycan. So the next thing that we are going to do is we are going to add something called grams iodine. It is iodine, okay? The thing is, grams iodine is what they call a mordant, okay? Mordant. It actually causes the crystal violet to kind of bind to itself and stabilizes it into these large chunks of crystal violet that have basically all anchored into this peptidoglycan. So it tangles it together. Okay. This is a stabilizer. It causes the dye to form large complexes in the peptidoglycan meshwork of the cell wall. The thicker gram positive cell walls are able to firmly trap the large complexes compared to the gram negative. So if I'm talking about making these big chunks of crystal violet stick together, it is definitely going to get more anchored into something thick like this than something thin like this. Okay? So when it comes to basically being able to stick and stay, because that peptidoglycan is so thick, it's a lot easier to get it to stay using that mordant, iodine, in my gram positive than in my gram negative because the gram negative doesn't have that much peptidoglycan. So it is more firmly trapped in large complexes in the gram positive than in the gram negative. Okay. So the next step, because I want to be able to tell the difference between gram negative and gram positive using this technique, we use alcohol, which can also be called the decolorizer. Okay. So it does exactly what that name says, decolorizes. It takes color out. Okay. You are going to basically add alcohol. Well, okay, so you've got your grams iodine. You're going to rinse it off with water. And then you're going to add 3 or 4 drops of alcohol. Now, this can be ethyl alcohol, it can be isopropyl alcohol, whichever alcohol. But what that does, what alcohol does in general, is it dissolves the lipids on the outer membrane and it removes the dye from the peptidoglycan layer in the gram negative cells. Remember that over here, my gram negative cell had this outer layer, right, of phospholipids. One of the reasons alcohol is so good at getting rid of oils is because it dissolves them. So it's going to basically take this layer off. Now remember, the crystal violet that has made these big, huge complexes isn't as anchored in this little thin layer here of peptidoglycan. So when you add the alcohol, it's going to take that top layer off, and it's also going to remove the crystal violet from this little thin layer of peptidoglycan. This is where you also kind of have to be careful. So with the alcohol, remember I said crystal violet's about 1 minute. Grams iodine, I believe, is 45 seconds. Alcohol is 12 seconds. You have to be real quick about it because if you leave it too long, it'll act like bleach on a black sweatshirt. Eventually, it will decolorize, even though you don't want it to. It will if you leave it too long. That's why we say 12 seconds. So if you look here, there's that outer membrane and there's the peptidoglycan of my gram negative. Now look, that outer membrane has come off, the peptidoglycan has come out, but here, those big complexes are still stuck in that peptidoglycan. So again, 12 seconds, rinse it off with water. We want to make sure the alcohol doesn't stay there any longer than that. Give me 1 second. Let me move this out of the way. Now, the whole point of this, the whole point of doing this is being able to tell the difference between gram positive and gram negative. So we need to dye the gram negative with something different, so it's a different color that we can see. The next step is actually using, okay, is actually using a different dye called safranin. So crystal violet is violet. Safranin is a bright pinkish red. Okay. Which cell no longer has any dye in it? Well, obviously, gram positive still has dye. The gram negative, however, we have removed that dye. There is no dye here anymore. So when we add the safranin, and this will be again for 45 seconds, okay, you are actually staining the gram negative bacteria. The gram positive will pick up safranin, don't get me wrong, but imagine having purple and putting pink into it. What color is it going to be? It's going to be purple because purple is the darker color. So regardless as to how much gram positive picks up that safranin, because it's already stained purple, it'll still look purple. So you let that sit for 45 seconds, rinse it off with water. And then when you look, you will see a difference between the gram positive that look purple and the gram negative, which will look pink. This procedure, this staining process, is a huge, or was a huge leap forward in microbiology because without us having to do any type of genetics or anything else, We literally could tell the difference between gram negative and gram positive using this basically 4-step procedure. So it it's essential that you understand how this works. Okay? This is hugely important for you to understand. Huge. Okay? So I want you to understand this. And I hope I'm beating you over the head with the understanding that this is very important. And again, it's not just about the steps, it's understanding why you are doing those steps. Okay.